Hello, my name is Gabrielle Rusch, and this is my Lab 2 report. So, a brief overview, this is a lab that's actually building on off of our previous lab, Lab 1. So, here's a brief glimpse, a brief review of our Lab 1. So, here are my expectations, our initial observations. The two U tapes were repelling each other, but they were attracted to neutral objects. The U tape that was positively charged was actually attracted to a negatively charged pen. It was attracted to my hand, and an experiment with two U tapes, both being positively charged. The tapes repelled each other with a distance of 1.3 centimeters or 0.013 meters. So here's my FBD. We have a static force upward, electrostatic force upward, gravitational force downward, making our net Y component of tape B being the top tape here, being the net Y component of the force of tape B would be 0. So what formulas were used in our calculations? So we first have Coulomb's law. There's calculation of the electric field using Coulomb's constant, and all of these formulas were used in both Lab 1 and Lab 2 calculations. So moving on from that, here's my Lab 1, a brief overview of my calculations. We have first calculating the gravitational force. The magnitude of that is 1.57 e negative 4 newtons, and you can use that to actually find the Q in coulombs, which is 4.75 e to negative 8 coulombs. The number of electrons calculated here were 2.97 e to the 11. So continuing forward with Lab 1, here's a reminder of the glow script that was used here. And it's a very basic shell, just kind of showing the different forces up. I had a specific scalar that I multiplied by just so that it would be more visually appealing and easier to see the arrows. And so here's the Lab 2 glow script. So it's definitely more complex, just a baseline looking at it. Additionally, we have a lot of differences here in the calculation. So let's first talk about the Q value. So as you can see, the Q value down here is actually e to the negative 9 versus for Lab 1, it was e to the negative 8. And I'll get to that more later, but it's important to first understand that we were asked to choose a sort of arbitrary n number, and that was, for me, I chose 10. And so that number, our n number, actually allowed us to integrate through the piece of tape. So why would we do that? The reason is that we are looking at this top U tape differently than in this lab versus what we did in the previous lab. In the previous lab, we looked at the piece of tape as an entire point charge by itself. But in this experiment, we were told to integrate through the piece of tape and and not treat it like it's a uniform point charge. So each individual piece acts differently, and what you can see here, the electric field at the upper tape is shown by the green arrows, which are all the same y direction but different x directions. They are spread out to show the different disbursements of force. The net force due to the lower tape is upwards, but due to the gravity is downwards. And the gravitational force is actually uniform at all parts of the piece of tape. So that's an important note for us. But as we can see here, the net force, electrostatic force, is upwards and net gravitational is downwards. And so this disbursement of different force of the electrostatic force is very important as we're integrating through. So why was there a difference in the Q calculation? So Lab 1, as I was saying, we were just treating it as a point charge, but Lab 2, it's not a singular point charge. We're exploring integration, splitting the tape up into n pieces. And so that's why when you're dividing the Q of Lab 1 by our n, which was 10, then we get the e to the negative 9 value, which is different from our e to the negative 8 value that we were getting for Lab 1. So just kind of going back over, if negatively charged, how should it interact? And it should have been repelling from the plastic pen, but both of the charges would still be repelling each other as like charges repel each other. So, just a kind of an overview of what we've learned here. There definitely was a difference in calculations in what we were focusing on here. We were treating it not as a point charge or a piece of tape, and therefore this calculation is much more accurate, I believe, because the tape is different at different locations. That there's different splitting it up in the different charge pieces, and so I think getting a more accurate picture is what Lab 2 was getting at. So I think that's really important for us. But thank you so much. This is the end of my lab report.